Okay, here we are. So, this just a repeat of from last class what we said. I felt that whatever kind of a job that you are going to do initially, at least in your career, either in one type of manufacturing companies or in engineering services companies, the two questions will keep on coming in different forms or other. So, I have just reproduced them here. One is if there is some product that is being talked about, methanol, acetic acid, you name it, whatever it is. Frequently the question is asked saying that how much does it cost to make that product. Okay. Second is, in order to produce that product, if you have to set up a plant of a certain size in a certain location, how much is it likely to be costing you to set up that plant. So, these are the questions that keeps on coming, and most of your work in some way or other, at least in the first few years of your career, will center around these two. Now, small variations in the emphasis could be there. For instance, if you join a manufacturing company which is primarily into making a stuff or making a couple of products, question number 1 will be of more relevance to you, obviously, because the plant is already there, it is operating, you are joining the plant. So, your focus etc. could be slightly different, though you should keep at the back of the mind Q2 also. Similarly, if you are an engineering services company, you have no product as it is, but you are all the time looking at your customers to see how well you can build the plants for them, and first question they will say, okay, tell me how much it is going to cost. So, there is a slight difference in the importance between the two sectors, but both are important. Okay. Question 1, manufacturing unit. So, with that we will give a little bit. Normally in a running plant, like I said, you are not going to be the employee number 1 in the plant, therefore, it has been running for some time. Lot of records will be available to your heart's content. Almost all manufacturing plants, big, small, this they are doing it very well. So, you will have lot of information, and if your role permits you, you can also have access, because some companies make this I do not know, for some funny habit they do not share it everyone among the employees. This is strange, but mostly good well managed companies will share the records with the employees at least. So, you will know what are the cost, including trends, because I said cost is related to the time at a point of time. So, if you wanted to know the trend, the way things have moved historically over, that also will be available for that. What is this relevance for? Is because once you know this, then your job focus will be to try and how to where possible bring down the cost. So, that is going to be the focus of manufacturing jobs. The second part, which I will not elaborate, but I just point out to you, is that there is also, if you are able to pull out a little bit extra output from the plant for a given plant, it has been running, if you are able to operate it and get little bit more output from the plant, that also will be welcome, that is where you will be asked to do. But that portion of so called debottlenecking extra production, I will keep it for a slightly later date, because today and next class cost part I want to get out with. So, basically your role will be to study whatever information, historical information is available in depth, then understand, identify between the two there are several elements, which one I should work on, prioritize, and then work out a strategy based on whatever basic principles that we have already been taught, and try and find out how the cost can be brought down. So, that is why this cost is relevant for a manufacturing job, that is well. There is an example later on I will get into by giving you a quick thing there. The important point to remember is, if you are at a manufacturing unit, if you are coming out with, after studying the historical trends, come out with an idea, I like to go about reducing the cost in this manner, some strategy will form. In that strategy, sometimes some additional equipment will be required, which is not present. So, here is a question where you are being asked to reduce the cost, but the first thing you will say is that give me more money to spend. So, this is important, and how to deal with it, the finance part I will link it up. So, keep it in mind, main focus is to reduce the cost, but of course, it is possible that you should initially spend more money in order to get money back. Okay. Heat recovery example straight away I will get into. Here I have to minimize. Yeah. This is a description of a real life incident, pardon my hand sketch, but I will explain to you what the thing is. You can see there is a rotary dryer, and this is drying a solid. So, the solids are coming at a certain temperature, certain moisture content, wet solids are coming in here, passes through the dryer, goes out completely dried, and it is found by experience at 100 degrees they more or less completely dry, you get the specification of required specifications. Of course, for a given wet solids, if it comes out let us say at 8%, in order to, if a requirement is to bring it down to let us say less than 0.5%, if you maintain this condition of the solids at 100 degrees, it is found that you reach that. So, these are the two endpoints. How to do that is, in this equipment you generate hot air, and pass it in a co-current manner. In this case co-current, that is not relevant for the problem definition, it can be co-current whatever depending on the situation. It comes in at 400 degrees Celsius, passes through the dryer, exchanges heat, and then the exhaust gases go out, and because it is a direct contact, rotary dryers are direct contact between the solids and the heating medium, you need to have some form of a de-dusting equipment. So, there is a cyclonic separator that is provided, fines are separated and returned back, and the hot gases are taken out by an exhaust fan, out it goes into the atmosphere 200 degrees Celsius. Why 200 degrees Celsius is, it is found that if you try to bring down this 200, then the product drying does not take place adequately. So, if you want to have solids retained at 100, the exhaust gases should be at least 200 and above. That is what is been experientially found. Guy who designed heat transfer equipment designed it like that. You are in the plant. Then this equipment is a furnace where the hot air is generated. You have a fuel which is burnt, and then air is supplied in two parts. One is called combustion air, which is the air that is required to burn the fuel into completely CO2 whatever, and the second quantity is called secondary air, that is in order to give enough mass flow rate across the dryer, so that you get the desired mass transfer coefficient, right. It is not as if you have a very small quantity of very hot air, things will work out. You need a certain amount of flow, because the mass transfer in the dryer depends upon the mass flow rate. Therefore, you put the secondary air here. One small point is, why not put both of them together, why two separate blowers and so on, because if the fuel has to be burned thoroughly, fully, efficiently 100%, the volume of the furnace should be as compact as possible, so that there is a radiant heat transfer and all that. Whereas, this air is only for diluting it to get that quantity. So, that is why it is conventionally most of the furnaces you will find there is a primary air or combustion air, and there is a secondary air or a dilution air separately kept. So, this is the thing. The problem is, in a running plant, it has been running honky dory, no problem. You go to the plant, you ask, can I have the cost? You are in charge of the section, by the way. There are a lot of things happening ahead, there are a lot of things happening downstream. I am assuming that you are in that section responsible for that. So, you get the cost sheet, your accountant comes and says historical data, everything is available to you, and you find that the fuel cost per ton of the product is slightly on the increasing trend, because fuel prices have been going up. You also do a second check to find whether actual consumptions in terms of the fuel in kg per hour or liter per whatever, in terms of quantitative numbers, it is not too bad. There are some fluctuations, but not too bad. But costs are going up because the price of fuel is going up. So, that is the problem that you are faced with. With this, let us go back to the question which I put. You are told, can you come out with a strategy for reducing that cost? So, what you would do, some of you must be thinking about it, you will each one depending on your innovativeness etc., you will come out with a scheme. Basically, you will find hot exhaust is going at 200 degrees Celsius, it is losing some energy. Can I capture that energy back into the process? That is what the logic is. You will, each one of you will come out with some configuration. The key point is, whatever you do, there will be additional equipment, and this additional equipment, how much will it cost? Will that cost will be small enough for you to gain the energy savings at the end of the project, will be the key issue. Okay. So, that is for the relevance of all this cost business for manufacturing thing. Now, this is for a running plant, easy, historical data is available, just pick it up, study it, apply your mind, you know what you are going to do, so on. What about sometimes you are asked that question number 1 is, you are thinking of producing a product. So, the plant does not exist, and the question is, how much will it cost to make the product? This actually is probably more frequent. There are so many innovative ideas, everybody comes out, we hear about the product. Always the question is, how much will it cost to make the product when you have no plant, you just only have an interest in that equipment, in that project. So, this is like I said, sometimes stoichiometry can give you some clue if you know the chemistry and so on, but mostly this comes from experiments conducted by pilot plant guys and so on. So, some sum of all this is there will be technology providers for that technology. They would have access to that information based on a lot of hard work that they do in the pilot plant. It is not very easy for anybody to get it there. So, in this kind of a situation where you are wanting to know about what will likely to be the cost of a product when there is no plant that is existing in your premises, you will have to rely on technology licenses and so on. But in spite of the fact, when somebody says I will tell you, like I am a technology expert, so you come and ask me, I give you some gyan. Oh, methanol you are interested, it takes 17,500 rupees per ton of methanol, like that I speak. You will have to take it with a pinch of salt, because all I said is you may have some respect for me, but I am just giving you a number, I have no plant to show you. So, the good thing to do is to look for whether a plant is running based on the technology that is being talked about. Obviously, there will always be one plant which is the first plant of its kind for any product, but for most of the products, generally speaking, this has all been done. So, you will have some plant running there, unless you are the first fellow who is going to bring up with that, then it is a difficult task together. So, where possible, it is advisable for the engineer to go around and look at a plant which has been built and which has been running, and then check it out, because those guys then have historical records. They may not easily share with you, but one can get around. So, that is what is the for the cost of making a product, both the manufacturing and a new thing. Now, I will switch to question 2. What was question 2 is, this is about a product, but what about a plant which makes the product, how much that plant is going to cost to set it up. So, this kind of a bit. Like I said, this question is probably more relevant to an EPCM role, because you are going to build that plant and so on. If you already have a plant, let us start with the simpler thing. You already have a plant, still you are interested to know how much this plant, now in the past tense, is not going to cost me, it has already costed. So, this is like, therefore, I put did it cost. So, if you are in a situation where you are a manufacturing engineer, you already have a plant running there, you just wanted to know these guys built this plant, how much did it take them to solve. Again here historical data is absolutely available for all plants, in great details they will give you whatever you want. But then one caveat, depending on the age of the plant, there will be something called depreciation. This is a new word I am slipping in the next class we will probably take it up. Most of you have a common idea about what depreciation is. With the time plants lose their value because they age or whatever happens. So, if it is a 5-year-old plant you are operating there, the number that the company will provide you will be what it cost 5 years back to set it up, because after it is built at one point of time you have got a number locked, then that is, so it is a 5-year-old plant. Oh, I see, that is what it got 5 years ago, is it? That information you will get. Typically the kind of records that will be available will be how much money was spent in land, acquiring land for that, buildings, road, site developments. You can look at read the list, it is pretty exhaustive. All that goes into setting up that unit would be captured and presented in some heading or other. The usual headings I have listed down here. This is the headings in which chemical engineers normally use: land, building, roads, site development, etc. Plant and machinery, which is the stuff like reactors, heat exchangers, pumps, columns, what have you. Storages are also included, storage tanks, both for the raw materials as well as for the finished product, or sometimes if your finished product is a solid, large warehouses where the solids are stacked up, whatever. Material handling equipment, the works. Then instrumentation, electricals, piping and valves, they go. They normally are not called as plant and machinery because they are accessories to plant and machinery, but that is a huge amount, especially if you have a fancy process which high temperature, corrosion, what have you, all fancy materials of constructions are used. So, electricals, utilities, piping, valves will have to be found, captured, and it is recorded separately. Utilities is those, in order to operate the plant you require, let us say, hot oil, steam, refrigeration, cooling tower, that kind of a thing, supporting, that will also have to be captured. Of course, civil work, the whole thing has to stand and stably and there, so you have to build structures, pipe racks, what have you, and initial amount of catalyst that was brought along with the plant, lubricants. You can see the kind of list, it is not exhaustive, it will run to pages. Luckily, in engineering practice, in good companies, they have a system, they will catalog all this and available. So, you just have to open the catalog, pay attention to each detail, you are by and large you are through with that. On top of these are hardware items, physical stuff that you can buy and so on. In addition to that, there is a software item, that means somebody would say I will build it for you and you have to pay for his brain power. So, things like engineering fees for building the plant, licensing, and there are guys, muscle men who come and lift equipment and place it in place. So, the construction cost of people, all that goes into that. So, in summary, it is a huge amount of data. Historical information of course is available. Why is this? We are worried about this plant. After all, the plant has been built, it is there, you can go and look at the access information you want. Why is it important? Because this installed cost of the plant determines the fixed cost, because in the earlier class I very fast I went through, there is something called variable cost which varies with the unit of production, fixed cost which is kind of dummy which stays there. So, this initial investment cost relates to fixed cost. So, therefore, you should know about that, and clever fellows try to build plants efficiently, safely, operable at as low a cost as possible, naturally, because you are putting your money, you would better if it is lower, accordingly the fixed cost also comes down. And later on, for financial evaluation of a business which is built on such products and plants and so on like that, this data is very important, and this also in the next class I will get into how this number comes. For the present, keep it in mind, historical cost of a running plant is available to you and so on. Same question, now we are raising this question from the perspective of an EPCM company whose job is to build such plants and hand it over to the customers for a price. Now, how do they do this? They do not have a plant yet. So, there is no question of historical. Sometimes there can be, because if you are a market leader, you have been in the business for some time, you will be building plants of this kind, not maybe every year, but at least within a span of 2-3 years somewhere in the world you would, and especially if you are globally these days, you would have built for some client somewhere else some plant of that kind, similar plant of that kind. So, you will have some, not absolutely blank, probably you will have some information. So, you can go back and refer to that, what happened there. Otherwise, what you have to do, you have to start from 0 and estimate it in a very detailed manner. Last slide showed what are the items, it was a horrendous list. Regrettably, this horrendous list you have to go through, list it out, and for each one try to figure out what will be the actual cost, all items included. On top of that, this we are doing it, let us say for today, this exercise itself will take about, for large number of engineers working together, typically will take 3 to 4 months, working till 11 o'clock in the night. It takes a lot of time to do that, but you are doing it over the next 3-4 months. The plant is likely to be built over the next 3-4 years. So, you will have to make some provision of, in the process of after taking decisions, actually implementing it, there is likely to be some escalation of the prices, right. So, today you ask somebody, he will give you a price, but he will say this is valid for the next 45 days, because who knows how the prices will change and so on. So, you have to provide for some contingency, which items which you have missed out, in spite of all this elaborate checklist, there are few items it is likely that you would miss out. So, you will have to provide for something unknown, plus for known items your costs are today's cost or next 3 months cost, but the plant is likely to be built over a period of time. Accordingly, you have to build in some escalation, and this itself is a great art engineers do. They take, in fact, Chemical Engineering magazine if you read, they come with realistic data of how things have moved for every class of equipment, valves, pipes, lined vessels, fired heaters, insulation material, the works you will have. So, there is some huge amount of database has been built up by the profession. So, you can lean on that and build it up, and this is what EPCM companies do even if they are not executing a project. The sheer question of addressing a client, how much is this plant likely to cost, is this amount of work is done. Of course, once the order comes, you have a target number, you have to work in order to make sure that the actual plant is built within that number. So, that is the kind of a Q2. Now, may I ask you why this information is relevant for two things. For an existing plant, meaning not an existing plant, for a plant which is likely to buy this. Why this is important? Because they would like to know at that price, is it worthwhile for me to get into that production. Like this one example I gave, heat recovery, you have come out with a scheme. Idea of the scheme is to reduce energy consumption, but you are going to come out with some scheme with equipment and blah 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 blah. For this, is it worthwhile that? Like that, if you are wanting to go into a new business of building up some plant to make a product, is that whole thing worthwhile? In order to take that valuation, financial valuation, this capital investment number is very much essential for the operator or potential operator of the plant, potential manufacturer. For EPCM guys, of course, that is their bread and butter. If you give that price and if you are not able to build it within that price, then you are not in business. So, this is a very important information. Let us go back to this quiz I said. Remember this dispenser, so on like that. These are the two questions there. How much will it cost to make that product, and how much money will I require in order to set up a plant of this size. Okay. Now, how to do this? All this theory which I gave in the last 15 minutes is all there, but you have to put it into practice. Quickly I will show you one sketch, then I will move on, but keep practicing. All this will be available in Moodle. Okay. So, the first thing is, like I said, always start with flow diagram. You know, the basic engineering, some class I said you have to have process flow diagram, P&I diagram, layout, blah blah blah, lots. So, it is hard work. Quick hand written sketch as a tip of the iceberg kind of a thing. Then the details you can see. I say that this process, what is going to make this dispenser, my process is like this. The plant is 100,000 dispensers per month, each of 200 ml. So, this is given in the requirement statement. So, what I do, I think of a process. You can think of another kind of a process. It is one type. In my process, what I say is, you know what I will do? This isopropyl alcohol pure 99.9% is available in the market from bulk producers. So, what I will do in my plant, I will buy this pure isopropyl alcohol, and how will I buy? Because I am in Velachery, I will buy it in road tankers. The manufacturer could be in Cochin, he can be in Mumbai, he can be in Navsari near Nasik, wherever, but I will buy from his plant and bring it into my plant by road tankers. That is my assumption. Then I will build a plant. This plant will operate on a single shift. Each one of them is a decision. There is nothing right or wrong, it has got a implication. So, I am just giving some simplistic thing. You can say, why this idiot is operating single shift operation? After all, a plant is built, you should operate it round the clock, then you will get more possibly. So, I am just giving some assumption, and 6 days a week it operates. Now, what I do is that the process is pure IPA comes, this material has got 70% IPA content. So, what about the balance 30% is, I make DM water, because DM water buying is a bit hard. So, I make DM water at my own plant, I blend this DM water with isopropyl alcohol in the correct ratio to get 70% IPA. Then I fill dispensers, I have an automatic machine filling up dispensers, pack them, sell it up. That is my process. Now, some guys may say that, why you are buying IPA, make IPA. So, then I have to know how isopropyl alcohol is made, propylene hydration. Then some guy, clever guy may say, you are an idiot, the highest value addition is coming from propylene. So, you make propylene, then I have to know how to make propylene from propane dehydrogenation. Then where that propane comes from, I have to think. So, this is the reality of life. So, somewhere when you make all these assumptions internally in your company, you will do this back and forth, why, and finally you will come to a logically at that point of time, what appears logical at least, some decisions you will take. All the plants that you are seeing today have gone through this. At that point of time, whoever has taken a decision, sometimes it is recorded, good companies record the decisions, the pros and cons, but anyway there has been some talk, keep it like that. Now, flow diagram I have written down. Here is my blending vessel up there. Can I show this fellow? Yeah. So, that is a blending vessel. What I have done is, here is a underground tank I provided. Now, question is, why did I put an underground tank? I thought that isopropyl alcohol, flammable, explosive, blah blah blah. So, below the ground I may velacheri, one fellow will come and jump at me, all that sort of. So, I put in another situation you can put above the ground, and every one of them has a cost implication. So, this is underground tank. Tankers will come by gravity, they unload into my tank, one tank, and then I put a pump, take it up to the process. Here I have put a measuring vessel. This measuring vessel is like a overflow types. You fill that vessel, beyond a point it will overflow back into the tank. So, at least volumetric dosages I am ensured. So, I fill IPA, I have got one IPA, great. Similarly, I have another one here. How do I make it smaller? DM water. Now, here I have skipped some details. I said DM water, I make a plant, then suddenly I am showing here only one tank. This is because I sat and prepared it yesterday night. So, believe me, like this I can go on starting from raw water, DM water, plant, and then all that, keep it in mind. So, DM water storage, similarly a pump, this is above ground tank, water, take it to another dosing tank, it overflows back. Now, this blending vessel, some operator will go open this IPA falls, open this water falls, or more appropriately looking at the operating instruction, first open the water, so that water fills the reactor, safety reasons, and then open the IPA, it goes, start the equipment, mix it. By trial and error I would have known out how long will this operation, after mixing it becomes uniform. At the end of it, it is ready, stop everything, it feeds the packing machine by gravity. Packing machine is a bought out thing. I tell these guys I want to fill that 1 lakh per month divided by 6 days a week, one shift 8 hours, all that I calculate and tell this fellow this machine should be 250 ml, so many number of packs should flow through the machine, like that I decide and give it out. It is a bought out item for me. Stick there, comes out, pack, fill, storage. I have here nicely avoided talking about storage of finished product. In reality, of course, you have to find where the hell it will get stored, because the moment you finish your production is not the same time where somebody is out there taking it in a truck and out of the plant. So, there is some. With this very crude flow diagram, let us go back. That is how it is. If you put that, then you have got something to talk about. You have got some flow diagram, hopefully you have got a P and A diagram, because I have in all these valves I ignored. I just said one mixing vessel and put one turbine agitator, axial flow, whatever agitator you have to say, the drive whether it is flame proof because IPA is being handled, how the motor will be fed, where the starters will be there, where the substation will be there, where the power will come, where the lighting will come, the whole lot of a thing will have to be thought of, and then you will be able to answer question 1 and question 2 reasonably to the extent that you have spent time in detail. Let us take a breath. Cost sheets are looking like this. For mostly variable cost and fixed cost, first case, in this case the cost sheet will look like that. You have items, whatever items that goes into the manufacturing process on this, and per unit of output, in this case one dispenser is my output, one dispenser 250 ml. What is the quantity used? What is the price at which it is purchased, called rate? This multiplied by that is the cost loaded to the product, simple, right? So, this is what it is. I have put some arbitrary numbers. Just to clarify the point, it is 70% IPA and 250 ml, right. So, just do a quick check, how much of IPA theoretically should be there? 250 ml is the output total, it is 70% by volume, let us assume. I should have clarified whether it is 70% by mole, by mass, whatever. Now, I am telling you it is 70% by volume. So, 250 ml 70% means 250 into 0.7, that is what should come. It will not come to 0.185, right, slightly lower, I hope so, you may number, but I put what 195 because in reality what will happen is evaporation, it is a very volatile thing. So, evaporation during the process, storage, handling, sometimes you will wash something, this will happen, that will happen. So, this is where the pilot equivalent experience comes in, are able to put number, and these numbers make a hell of a lot of impact on the cost. So, that is how it goes, but a starting point will be a stoichiometry, at least because if I put something like 0.2 or 0.11, you would laugh at me saying that, sir, ye kya chori chal raha hai? I mean, are you giving IPA or some water is being like milk, So, Stoichiometry is absolutely essential, but on top of that one has to take experience. The difficult items are like power is how did I get, then you have to list out all the drives, including the if you have a control room and you choose to air condition it, that. So, all sorts of powers will have to get into that, estimate it, and then you should have a reasonable how many hours they will run, at what load they will run, because these things sometimes run at variable load, all that. So, that is the only way to do it. Packing materials also I have added, here also there will be some waste of the packing material. So, this is how the variable cost is looked at. For the again cost sheet for the fixed cost is, this I said is related to the investment plant cost, right. So, items are maintenance, manpower, depreciation in any class set, overheads. This will come again based on your design of what it is. So, let us say if it is depreciation, it is a percentage of your initial investment cost. So, if you know the initial investment cost, depreciation can be calculated. Manpower is, now you will have a picture, okay, there is some unloading station, there is some packing thing is happening, there is a reactor on top, there is something else, whatever happened, maybe there is a guard who is standing on the door and controlling, there is an accountant who is writing, whatever the stuff is. So, you have to visualize that plant and provide for a reasonable amount of qualified manpower, important words, reasonable amount of qualified manpower, pay them well, market rate calculated. So, that is the job of actually an engineer. Of course, some management short circuit it and finally land up with a problem, but engineering practices, it is the job of the engineer to decide how many number of people are required, because you know the process inside out. Okay. Investment cost sheet, this will look like, again going to our hypothetical example, I have to, after doing this sketchy process flow diagram, I have to size the equipment. I skipped over the data saying that what should be the size of all these vessels, pumps, tanks, you have to size it out based on some logic and then lay them out in a reasonable play, minimum distances, all that will have to be looked at. And then if it has to be located inside some place, how much of land area will be required, there are guidelines, codes available for solvent, and then that land cost will have to come there. Similarly, reactor is left hanging in the air in my sketch, actually there will be a building probably. So, the building, whether it is steel building, civil building, first floor, second floor, walkway, stairway, all that will have to be thinking through, put that building, of course, plant and equipment, valves, utilities, electrical, the whole works in this case. Safety, one of the thing I mentioned is DM plant, just as an example, then I will move on. DM plant, you get water, very clearly you demineralize it more or less first cut, which means what, all the calcium, sodium ions are all, cations and anions are removed. What happens to these anions and cations, by the way? Water comes out pure, but after some time you will backwash those resins in order to regenerate them. So, you will generate some effluent and that effluent can't be just let out. So, you will have to probably treat it. This has to be captured in the process flow diagram and in your engineering calculations. Just as an example, all the vessels whatever you do will have a vent, through the vent some organic vapors will be going on. So, you will have to have a vent VOC control incorporated. This is a plant handling solvents. So, there is always a 1 in a million chance something unusual will happen, lightning for instance, and something catches fire. So, you must have a firefighting system. So, the underground sump, diesel driven, because electricity is not there also, your pump should run. So, some diesel driven pump, fire hydrants here and there, automatic systems, sprinklers, cost has to be brought in. So, if you fill in this cost sheet like this, for our trivial example of that plant, you will have a reasonable idea how much will it cost to set it up for the technology that you chose. The technology being by pure IPA converted into 70% IPA. If you chose a technology which is starting from propylene for instance, it can be a completely different set of answers. Okay. Key point here being that more the detail, better you are, and the detail key person is the chemical engineer, process engineer. Lot of other engineers will come into the picture, of course. You would have seen some civil estimates have to be made. The fellow will ask saying that, can you tell me what is the loaded weight of the tank? So, you have to give me your tank and with solvent and with water sometimes, because IPA is less dense than water, but you give with water. You know why? When it is going to be tested after completion, you will fill it up with water and do a hydro test. So, it should stand that. Of course, in running it will take solvent. So, this kind of a detail the chemical engineer, process engineer provides, rest of the fellows jump in and put it. I will skip this. Key point is here, the more you start thinking yourself holistically, meaning end to end, your process design will become better and better. Like example in that thing is, we quickly went through, should I start with propylene, even propane, or even a close by refinery, you can endlessly go through, right. The ability that you connect here and there and then come out with is a key, and that key is rests with a chemical engineer, because by that time you will know what are the global, Professor Nagarajan later on will come through that. You will also know, am I doing like this, but am I the first guy in the universe to think of that? Maybe somebody has thought through that. What is this trend? Who else is making it? What, all that sort of a thing you will go through. So, holistic thinking is absolutely essential, plus strong chemical engineering, of course, sizing of stuff. Now, take a deep breath, go to, this is a trivial example here. Who wants to put 250 ml? Big time question is, we want to set up a 1500 tons per day plant in some location making ammonia. 1500 tons is again a fairly smaller plant, by the way. Recent tendencies to go for 3500 to 5000 tons a day plant. That is the kind of thing that people are working on. But anyway, for this example, and it uses natural gas. Answer these two questions. How much will it cost to make ammonia from the plant per ton? How much will be the cost of the plant? You can imagine the horrendous task there. Just to have some fun, I showed one flow diagram. It is not even a flow diagram, it is a part of a flow diagram. Look at this, it is a standard reformer, right, steam reformer. Fuel comes, desulfurization, reforming, primary reforming, secondary reforming, CO2 conversion, low temperature, high temperature, synthesis gas, recirculation, refrigeration, CO2 removal, blah blah. Normally, before this horror I will come there. Normally till now, because there is so much that we have to learn and of variety things, fluid mechanics, thermodynamics, reaction engineering, process control, what have you, data analytics, we normally skip over flow diagrams, right. It's everybody's tendency, flow diagram comes, move on, absolutely sensible, because there is no point in trying to read something and how many you will remember anyway and what is the use of remembering it anyway. So, but this is where that transition comes between, if you choose an industrial career, this damn thing becomes lifeline for you. So, that transition you will have to prepare. Obviously, you can't be preparing flow diagrams for all the chemicals that is known in that. So, if you during the course more or less target 1 or 2 types of industry segments to begin with, and then focus on that and try to look at flow diagrams with a slightly different understanding, I believe it will enormously help you when you face the company's interviews and so on like that. You will not be at a blank slate. So, this is the connect which I want to keep it for that. Till now flow diagrams only I have been talking about, right. Now, I have to tell a word about this P&A diagram, which is a deadlier version. The deadly fellow is like this. Earlier thing you saw one section of an ammonia process plant, lines going here and there and all. What about this guy? Is one piece of equipment, something called oil water separator. His job is oil and water come together in some proportion. In that equipment you separate them into two and take away two fellows to two. This is as simple as that. Look at the amount of gory details that goes into this, and probably this is not even complete. A well experienced process engineer will come and say, hey MS, you built this P&A diagram, it sucks, possible. So, look at the amount of detail that is coming in. All the instruments, line sizes, valves, type of valves, whether they are air to open, air to close, everything has to be brought into that, because this is the only language that is spoken among the entire team of people to be able to find the cost. So, it should be absolutely detailed enough to convey the meaning, so that clarifications are minimum. Even then you can call up and ask for clarification. And one piece of equipment for an ammonia plant, the earlier fellow, everything is converted into Paine diagram of this type. So, that is the job. So, next time let us look at the process flow diagram with a slightly more different respect. Okay. Now, this is an assignment, self study is not grading, nothing of that kind, but I would recommend you to, and there is no time limit for submission by the way, but do it for your thing, because this will bring into anchoring the concept of capital cost and operating cost in your jargon. So, self study. So, just pick a chemical in common use, please pick up a simple chemical, do not go for vitamin K. So, take a simple chemical and study, try to find out process flow. These days net has so many things, it may not be perfect, but you have something. Instead of trying to start from the scratch, you will be able to take some flow diagram and read it, but this time appreciate the flow diagram from the context of what we are. Acha, oh, that is what these guys are doing, well that do not need to remember anything, just appreciate flow diagram, and from there you will get to know what the equipments are, that is one. Secondly, if that was a process, some guess about what could be the variable cost of that product, because it will show some raw materials, all that. And third, which is till now we have skipped the capacity. Flow diagram is flow diagram, but for a 5000 tons per day flow diagram and 1000 tons flow diagram will look similar, right. But why then people build bigger and smaller plants? Just speculate on that. What is the range of capacities that we are talking? This is to drive home the point that our thinking from micro level will gradually shift into mega levels, and very smoothly, seamlessly we will be able to do. Just to give you that flavoring only I am asking you to do that study, no time limit, choose any one of them, interact. If you want to interact, I love interaction, so I will open some discussion forum on this, let us keep interacting for that. Okay. Now, I am going to ask you, it is 43. Next lecture 4-5 slides I want to talk, it will take 10 minutes. Shall I do, or it is too much, let us say and go. I request you to consider if it is 10 minutes possible for that. So, because till now cost, fixed cost, variable cost, all that we had some idea. If you do more and more, you will get a very good, that is all you need to know about the cost, absolutely believe nothing more. And why this cost is relevant also I touched upon, saying that it is used for financial evaluation. So, the next topic of getting into financial evaluation, I want to lay the groundwork in today's next 10 minutes. Then on tomorrow is mercifully a holiday. Monday class we can take it up and do a thorough analysis of this finance. At that end, you are completely mastered finance as far as I am concerned from the point of view of an engineer. All you need to know about finance for your career, you would know by that time, essentials. Then if you choose to get into finance as a specialist, you can fine tune on that. Okay. So, finance I will put it like this, it is simply who owns the company. Of course, not one person, several people will own. So, the proportion of who owns the company, that is the first thing. So, who funds, owns means who gave the money, funds the company. Second question parallel to that, how the hell it is spent. So, this Jatakam or history is what is all finance about. There is a jargon that comes in financial circles, therefore, I think you should know the jargon sometimes, because sometimes jargon is used more to confuse rather than to clarify the picture. So, better we are equipped with that, so we are not fussed by this. Something called liability is used. This liability is another word of who gave the money. But why liability is because for the company which receives the money from the owner, it is liable to the owner, right. That is how we should see it. Why the liability word comes? Because from the company's point of view, it owes the money to someone else. So, the owner's money is called liability, and sometimes it can be owner who gives in one kind of a money, it can be somebody who loans the money. He is not a owner, he takes a slightly different role, but he gives money. So, these are two types of fund providers, somebody who owns, whose commitment, whose involvement, who is a slightly different compared to somebody who just gives you money, do that. Assets is how do you use the money. After you get the money, use it on a variety of things. For example, you can build a plant, therefore, plant and machinery, land, you can buy raw materials, product, whatever it is. So, source and use, that is what the whole of finances jargon we have gone through. Slide 1 gone. 2, again another jargon is balance sheet. This balance sheet is lovely, it is called, it always balances. That is the wonderful thing about it, like mass balance, energy conservation, momentum conservation, spin, quantum numbers. This is finance guys have got this balance sheet. This one, it says always for a company at any point of time the assets will be equivalent to liabilities, and it is talked as a big deal. Actually if you think of it, of course it should be, for any transaction there are two parties, right. I give money, what I give and what you receive have to be the same, it cannot leak out and go. So balance sheet is, that is all it is. So it tells you the financial position of a company at a point of time, indicating that at that point of time the source of money is like this, the use of money is like this. In other words, this is how we have spent, this is how we owe money to the people at that point of time. So it will always balance. How frequently it is prepared? By law in India at least and universally, once in a year you have to prepare this and get it checked by the independent agencies and publish it to the shareholders. Sometimes some countries insist, like India, once in 3 months you have to do. So this balance sheet business of the company you will get it in once in 3 months. By law it has to be prepared. Okay. There is another variant of this, this like COVID-19 comes in various forms. There is another thing that comes attached along with this, which is called profit and loss statement, called P&L statement called. It is part of balance sheet. Balance sheet, again to recall what it says is, at a point of time who has given you money, how the money has been spent, just a statement. I am going to show you the statement in a minute. The other is, similarly at that time, did that entire all the whatever you are trying to do, that activities, did it result in a profit or not? That is called the profit and loss statement. This is a cumulative snapshot. Balance sheet is at a point of time, take a photograph at that point of time, assets, liabilities. But company life runs. So typically again here a period is to be defined, let us say a period of 1 year, statutorily yes. During that period, during is the word, during the period of that 1 year, what all you did in terms of buying, selling, investing, this, that etc., you put all this sum total and figure out what is the profit. Profit being revenue minus cost from the previous and show that. So a balance sheet of a company and all finance will be, one is balance sheet, second is profit and loss statement. How is that they are linked? Again a trivial example I will give, then you can open up, I will give some exercises. Let us say a company starts with 1000 rupees on day 0. Now this 1000 bucks has to come from somewhere. So I have given saying that 400 the owners, 3-4 guys join together and say we are owners and we are all contributing money. So their money is 400 bucks. Then they also went and asked somebody to give them loans, which is 600. So 400 owners, 600, total is 1000. What is the liability? 1000. What is the asset? 1000. 0 date. Then they take some activity, whatever it is, using this money do stuff. 1 year passes. Then they sit back and then find during that year they have got revenue of 1000 bucks. Maybe I to avoid confusion I should have put 500, because this 1000 and that 1000 are different, you are aware of that, no? 1000 is starting money, this is during that year you sold stuff and revenue etc. came 1000 bucks, and you also spent a lot of money in getting that revenue. After netting of both, you got a net profit of 75 rupees. That comes. Now first question is, this 75 rupees, it is luckily profit, something remains, okay, we are happy. Who has a claim on that 75? Imagine at this point of time you have paid off your cost, which means salary is paid, raw materials are paid, electricity bills are paid. So this 75 obviously belongs to whoever has provided the fund. Owner, oh, you guys are capitalist guys, yeah. Owners, I mean, who provided the funds, because it can be owner, it can be fellow who gave that loan also. So that is what it belongs to. So 75. So next slide, probably that is where the balance sheet now at the end of that year will be, beginning of the year asset was 1000, liability was 1000. End of the year asset will become 1075. How? I just added that 75 to that, and I also increase the liability 475. I am a capitalist. Actually, it is wrong. What we should do is that out of that 75, you should find is there any interest payment due, because these guys who provide loan, they take interest. You have to first pay them off. After paying, if that 75 remained, then this number is correct. Otherwise, this is not correct. So, that is, so that is all that. This is my last slide, then we can happily close for the day. Refer to some annual reports of companies through the net. This is something which you can do over the next few months. It is available these days. Google provides such. You go to the company website, annual reports, click latest one. The advantage of this is the trends of that company, financial performance is available. It has two purposes. If you are thinking about a career about a company, it gives you a good information about what sort of a company it is. Of course, there is a lot of hype. Nobody in the company comes and says, you know, I have some problems as well. So, everybody hypes it up like we hype up our CV, no problem. So, it is good, still you will get to know a little bit about what that company is. It's worthwhile to know. This information is very useful, because if you are going for an interview with a company, it is always better to go with some idea about what the company is engaged in, so that you can have intelligent discussions, your role, all that will make sense if you know something about the company. So, pick some company of your choice and try to read that balance report, that is one. Secondly, like 20 minutes back I said, you calculate variable cost, existing plant, new plant, investment cost, all that I said, and I said something called financial evaluation. For financial evaluation, these numbers will be available in the balance sheet. So, that is the advantage. So, we will stop here. In the Monday class, what I will do, I will continue from this finance. How does it, the slide is supposed to tell you the number of information about, as an engineer, what role you have to play in the finances of the company, and it is a very important role. So, for which I have laid the basis, that is all you need to know. You by now, I think if you revise it, you will know what costs are, various types of costs broadly. You will know investment, little bit about, you are known about the balance sheet, financing, who owes money, how frequently they are prepared. Now, we will take a deep dive, every single decision of an engineer, how does it affect the finance of the company is what will be the next, another 20 slides or so will be the next class. With that, we will say, okay, enough groundwork has happened, now let us get on to where are these chemical engineering problems, will be the rest of the whole sessions from there. Okay? Great. So, I will post this anyway ahead of the class today, I will put it, so that you will have some chance if you want to read through ahead of time, read through that, but we are going to go through more in Monday.